Good morning to everyone.
Good morning, sir.
Good morning, sir.
Good morning. So today we are we are again solve some of the problems in maxima minima. Okay, and then still we have constrained maxima minima and Lagrange's multipliers. Then the first unit will finish. So I will try to finish as early as possible, and also we need to solve more problems. Okay, so that is up. So that's why I am expecting the answer from your side. If you tell the answer, then we will solve little bit. I think instead of 3 problems, we can solve at least 4 problems per day. Okay, we will try. Examine the extrema of the function f of x comma y equal to x square plus xy plus y square plus 1 by x plus 1 by y. So this is the function. We should find the extrema. Extrema means maxima or minima. Okay. So now I find the fx. Fx means you know that dou f by dou x, 2x plus y minus 1 by x square, and then fy. Fy is x plus 2y minus 1 by y square. Fxx. Fxx is if you differentiate partially with respect to x, you get 2. If you differentiate minus 1 by x square with respect to x, you get plus 2 by x cube. Fxy. If you differentiate fx partially with respect to y, this is 0, this is 1, this is 0. Fyy. From fy, I got fyy. This is 0, this is 2. Here we'll get plus 2 by y cube. So after getting the 5 partial derivatives, so we need to equate fx is equal to 0 and fy equal to 0 and solve these two equations simultaneously. Find the stationary points. So stationary points, the other name of stationary points are critical points. Critical points or turning points. Or you know that is a stationary points. Okay. Now I am going to equate fx and fy equal to 0. So fx is equal to 0 implies 2x plus y minus 1 by x square. Okay, this is equal to 0. So and then fy equal to 0 implies x plus 2y minus 1 by y square equal to 0. So I call this is equation number 1. This is equation number 2. So now I am going to subtract 1 minus 2. If I subtract 1 minus 2, you will get what? X minus y plus 1 by y square minus 1 by x square equal to 0. Equation 1 minus equation 2 implies, please check it, x minus y plus 1 by y square minus 1 by x square equal to 0. So now x minus y plus, we take LCM x square y square, get x square minus y square equal to 0. So now should take x square y square as LCM, we'll get x minus y into x square to y square plus, you can write x square minus y square is x minus y into x plus y is equal to 0. So this implies the numerator is equal to 0. The numerator you have x minus y is common. Remaining you have x square y square plus x plus y equal to 0. So either this is equal to 0 or this is equal to 0. Okay. I neglect this one. So I neglect this one. So because if you consider this is a quadratic in x or quadratic in y, okay. So the roots are complex or okay. I think you'll check it. The roots are complex. Otherwise, it is not in the nice form to find the values of x and y. So that's why I leave this expression. Okay, don't consider this is equal to 0. So only I could take x minus y equal to 0. So this implies x is equal to y, or you can write, first you should write x minus y equal to 0, and then you can write x is equal to y. Okay. Now after getting x is equal to y, substitute x is equal to y in equation 1. Equation 1 or 2? What is equation 1? 2x plus y, 2x plus y minus 1 by x square. 2x plus y, 2x plus y minus 1 by x square. So now instead of x, I am going to substitute y. So 2y plus y minus 1 by y square is equal to 0, or 3y minus 1 by y square equal to 0, or 3y cube minus 1 equal to 0, or 3y cube minus 1 equal to 0, or y cube equal to 1 by 3. This implies y equal to 1 by 3 whole power 1 by 3. We know that x is equal to y. This implies x is also 1 by 3 whole power 1 by 3. So the stationary point is stationary point is 1 by 3 whole power 1 by 3, comma 1 by 3 whole power 1 by 3. Now, so you should investigate, you should find the value of a, b, c and delta at 1 by 3, comma 1 by 3. So calculate and tell what is the a value at this point. What is a? A equal to
So
2
8
plus
is coming.
8. Yeah. So you should write 2 plus 2 by x cube. So this is x. X cube is 1 by 3. So 2 plus 3 into 2, 6, 8. Okay. B is 1 because it is independent of x and y. So B is 1. C is again 2 plus 2 by y cube. This is y. Y cube is 1 by 3. So 2 plus 6, 8. Okay. Now delta equal to AC square, sorry, AC minus B square. So 84, sorry, 64, 8 into 8, 64 minus 1 equal to 63, which is greater than 0, and A is greater than 0, and hence this point is minimum point. Find the minimum value. is minimum point. The minimum value f of x comma y is equal to, anybody got the answer? X square,
3 power 4 by 3.
3 power 4 by 3. Yes, correct, Manikandan. But we will do it step by step. Here x square. So x square means 1 by 3. This is x whole power 1 by 3. X square means 2 by 3 plus xy. So xy means you need to multiply these two. So 1 by 3 whole power 1 by 3 into 1 by 3 whole power 1 by 3 is 1 by 3 whole power 2 by 3 plus y square. Y square is 1 by 3 whole power 2 by 3 plus 1 by x. 1 by, this is x. So 1 by x is 3 power 1 by 3. Similarly, 1 by y. 1 by y is 3 power 1 by 3. This is x, this is y. So this is equal to 3 times 1 by 3 whole power 2 by 3 2 times 3 power 1 by 3. Okay, so this is 3 into 3 power 1 into 3 power minus 2 by 3. 2 times 3 power 1 by 3. So 3 power 3 minus 2, 1. So 1 by 3 plus 2 times 3 power 1 by 3. So 3 here 1 times 3 power 1 by 3. Here 2 times 3 power 1 by 3. So 3 times 3 power 1 by 3 power 1. This is nothing but 3 power 4 by 3. The problem is over. So this is the minimum value, and then so now for the next problem, you need one more definition, but that definition I gave in the first class of maximum minima. Okay, just I am going to read that definition. So please check in your notes. Okay, so a function f of x comma y is said to have relative maximum. Okay, a function f of x comma y, function f of x comma y, okay, is said to have relative maximum or simply maximum at x is equal to a and y equal to b, at x is equal to a and y equal to b, if the condition is f of a comma b is greater than f of a plus h comma a plus h comma b plus k for all small values of h and k. H and k. And similarly, we can define a function f of x comma y is said to have relative minimum at x is equal to a or simply minimum Okay, relative minimum or simply minimum at x is equal to a and y equal to b. If f of a comma b, f of a comma b strictly less than f of a plus h comma b plus k for all small values of h and k. Okay, so now I'm going to use this definition to solve the next problem. So the problem is discuss the extrema of the function. Discuss the extrema of the function f of x comma y is equal to x square minus 2xy plus y square plus x cube minus y cube plus x power 4 at the origin. So solution. So we need to discuss the extrema of the function at the origin means 0 comma 0. So f of x comma y is given. So find fx. So what is fx? You can tell 2x 2x anyone minus 2y plus 2x plus 2 minus 2y plus 3x square plus, okay, please wait. I want to check the problem. Yeah, it is correct. Okay. So x square minus 2xy plus y square plus x cube minus y cube plus x power 4. Okay. So 2x, sorry. So 2x minus 2y, and this is 0 plus 3x square and then this is 0 plus 4x cube. And then fy. Fy, this is 0. To differentiate with respect to y, you get minus 2x plus 2y. This is 0 minus 3 y square. This is 0. Next, fxx. Fxx is 2 plus 6x plus 12x square. Fxy. Fxy is with respect to y, so minus 2 minus 2. Fyy. Fy 0. This is 2 minus 6y. Now, you should check the origin 0 comma 0 satisfies fx and fy. If I substitute x is equal to 0 and y is equal to 0, it satisfies fx is equal to 0. So 0, 0, 0, 0. Okay. Here also 0, 0, 0. So the origin the origin 0, comma 0 satisfies the equation fx is equal to 0 and fy equal to 0. Okay, so next we need to find the ABC value at 0, comma 0. So what is A? A is 0. B is B is minus 2. C is plus 2.
Sir, is the value of A 2, sir?
Okay, 2. Sorry. A is 2. So now delta is AC minus B square, that is 4 minus 4 equal to 0. If delta equal to 0, then what is the conclusion?
Doubtful.
The case is doubtful and the further investigation is needed. Okay. The case is doubtful and the further investigation is needed. Doubtful and the further investigations are required to decide the nature of the nature of f of x comma y at 0, comma 0. Okay. So then I am going to use the previous definition, okay, to find the nature of the function f of x comma y at the origin. Okay, that's why now I am going to consider. So let us consider the values of f of x comma y at at 3 points close to 0. Close to 0, comma 0. So namely at h comma 0, comma 0, comma k, 0, comma k, and h comma k, and h comma h, which lie on the x-axis, comma y-axis, and the line x is equal to y or y equal to x respectively. So I have considered 3 different points which is very close to 0, comma 0. So this point lies on the x-axis, this point lies on the y-axis, this point lies on the line y equal to x. Okay. Now I'm going to find f of h comma 0 and f of 0 comma k and f of h comma h. So f of h comma 0. So please tell what is f of h comma 0? H square minus 0 plus 0 plus h cube h square h cube minus 0 plus h power 4. This is equal to h square plus h cube plus h power 4, which is greater than 0. Which is greater than 0. Similarly, f of 0 comma k. 0 comma k is 0 minus 0 plus k square plus 0 minus k cube plus 0. So you get k square minus k cube. So you can write this is equal to k square into 1 minus k. So this is greater than 0 if k lies between 0 and 1. And f of h comma h equal to h square minus 2h square plus h square plus h cube minus h cube plus h power 4. So minus 2h square plus 2h square gets cancelled. H cube minus h cube gets cancelled. So h power 4. So which is also greater than 0. So this implies f of x comma y greater than f of 0 comma 0. F of 0 comma 0 in the neighborhood of the neighborhood of 0 comma 0. So therefore 0 comma 0 is the minimum point of the function f of x comma y. Minimum point of the function f of x comma y, and the minimum value is the minimum value of f of x comma y equal to, if you substitute 0 0 in the function f of x comma y, you will get 0. Okay, suppose if you have any doubts or clarification in this problem, you can ask me. Otherwise, I will go to the next problem. Because this is not the ordinary problem. So this is slightly different problem than the previous problem we solved. Because here we are not finding the stationary points. Here just we are checking the points given the question satisfies the origin, satisfies, and then that is delta is 0. That's why further investigation is needed. For this, I am taking these 3 points. Okay, so these 3 points, one is here h comma 0, the another one is 0 comma k, another one is the point lies on h comma k. So I'm taking point very close to the neighborhood of 0 comma 0. I'm taking 3 different points. Okay, so I'm check. Even you can take some other points. Okay, so for my convenience, I'm taking these 3 points. So even you can take some other curve. Okay. So, but it should be very close to the origin 0, 0, and you should check it whether it satisfies the same condition. So, any doubts? Okay. So now, practice problem. So this is the problem in the exercise. Okay. Exercise problem. So try to solve and verify the answer. If you have any doubt, you can ask through WhatsApp. X power 4 f of x comma y. Okay. F of x comma y equal to x power 4 plus x square y plus y square at the origin. The question is, you should write like this. Discuss the extrema of the function f of x comma y equal to x power 4 plus x square y plus y square at the origin. Okay. Next problem. Examine the extrema of the following function. Class ரொம்ப சைலண்டா போயிட்டு இருக்க மாதிரி இருக்கு. Examine the extrema of the function sin x plus sin y plus sin of x plus y 0 less than or equal to x comma y less than or equal to pi by 2. So now I need an answer from your side, because last half an hour, nearly half an hour, just I am speaking, but I need your contribution now. This is f of x comma y. Okay. So anyone tell first 5 partial derivatives? Anyone? What is fx? Can you hear my voice?
Yes, sir.
So then, what is fx?
Sir, cos x plus cos x cos y.
Cos x is correct. Okay, wow. Yeah,
We need to expand that sin of x plus y.
cos x, this is 0. This is cos of x plus y. Okay, wow. Very good. And then fy.
Cos y.
Cos y plus cos y.
Cos y. This is 0. Cos y plus cos of x plus y. Okay. And then fxx. Differentiate partially with respect to x means minus
Sin x.
Minus sin x minus sin of x plus y. Okay. And then fxy. Fxy is what? This is 0. This is minus sin of x plus y. Okay. Fyy. Fyy is minus sin y minus sin of x plus y. Okay. Now Equate fx is equal to 0, fy equal to 0. Fx is equal to 0 implies cos okay, cos of x plus y equal to minus cos x. Cos of x plus y equal to minus cos x. Fy equal to 0 implies cos of x plus y equal to minus cos y. So left hand side is same, so hence right hand side is same. So this implies minus cos x is equal to minus cos y, or cos x is equal to cos y, or x is equal to y. Okay, so this is now I call this is equation 1 and 2. Okay, fx is equal to 0. So this is 1, this is 2, this is 3. So sorry, this is 3. So now substitute x is equal to y in this equation, the first equation. So first equation implies cos of x is equal to or y equal to x, cos 2x is equal to this x plus x is equal to minus cos x. So cos 2x is equal to
2 sin x cos x.
Minus cos x. What you told? I don't understand. I can't hear you. What is the x value? You got the x value? So minus cos x you can write cos of pi minus x, because pi minus is what? The second quadrant. So second quadrant is minus, cos is minus. So cos of pi minus x is cos x. So left hand side is cos 2x, right hand side is cos of pi minus x. This implies 2x is equal to pi minus x, or 3x is equal to pi, or x is equal to pi by 3. But we know that x is equal to y. This implies y is also pi by 3. Y is pi by 3. So we got the stationary points. This is the stationary points, pi by 3 comma pi by 3. Now your work stops. So at pi by 3 comma pi by 3, what is A, what is B, what is C, and what is delta? Okay. So A is what? A is minus sine x. X is pi by 3 minus sine of x plus y. X plus y is pi by 3 plus pi by 3 is 2 pi by 3. So this is minus sine 60 is root 3 by 2. Sine 2 pi by 3 is also sine pi by 3. This is same as sine pi by 3, because you can write sine 2 pi by 3 equal to 2 pi by 3 equal to sine of pi minus pi by 3. So 3 pi minus pi, 2 pi by 3. So pi minus again is in the second quadrant. So second quadrant sign is positive. So sine of pi minus pi by 3 is nothing but sine of pi by 3. So sine 2 pi by 3 is same as sine pi by 3. So minus root 3 by 2 minus root 3 by 2. So you'll get minus root 3. So what is B? B is minus
minus root 3 by 2.
minus root 3 by 2. Yes, correct. So minus sine of x plus y. X plus y is 2 pi by 3. So as I told already, sine of 2 pi by 3 is same as sine of pi by 3. So and hence sine of pi by 3 is root 3 by 2. So minus root 3 by 2. C. C is minus sine y. Y is pi by 3 minus sine x plus y. X plus y is 2 pi by 3, which is same as in the value of a. So you can directly write this is equal to what? Root 3 minus root 3. And delta equal to AC minus B square. So 3 minus 3 by 4, 3 minus 3 by 4, that is 12 minus 3, 9 by 4, which is greater than 0, and A is less than 0, and hence the point pi by 3 comma pi by 3 is delta is greater than 0 and capital A is less than 0. This implies the point pi by 3 comma pi by 3 is the maximum point. So anybody find the maximum value?
So 3 root 3 by 2.
3 root 3 by 2.
Yes, 3 root 3 by 3. Yeah, correct. Maximum value of f of x comma y is equal to actually sine pi by 3 plus sine x, so sine pi by 3, sine y, so again sine pi by 3 plus sine of x plus y 2 pi by 3. But sine 2 pi by 3 is also same as sine pi by 3. So root 3 by 2 plus root 3 by 2 plus root 3 by 2. So final answer is 3 root 3 by 2. Okay. Now the practice problem 2. Find the maximum and the minimum value of f of x comma y. Okay, sin x into sin y into sine of x plus 1. Here it's a product. Okay, 0 strictly less than x comma y, comma strictly less than pi. So this is not that much easy compared to the previous problem, but you can try. If you have any doubts or clarification, you can ask to me. I will tell you. I will explain you. So okay, and instead of this instead of these values, they will give something like I think in the integration, find the integration double integration in the region x is equal to 0, x is equal to y is equal to 0, and x plus y equal to 2. Similarly, here also they will give the region instead of the interval. Instead of the interval, they will give the region also. So that means here this is y equal to 0. x-axis, this is y-axis, this is x equal to 0. So this is the line x plus y equal to 2. So why using this region, you should find the point, the points you obtained from fx is equal to 0 and fy equal to 0. That stationary point, which is those lies in the inside the region, you should consider. Suppose if it lies here, there is no need to consider. Okay, so similar type of problem is also I will give the next class. So for practice, okay, and if suppose if you find in the net, you can post in the group. Okay, and then okay, next heading is constrained maxima minima. Next heading is still have time. So now, so just I will read from your book. Okay, suppose even if you have your book, you can take. Okay, so sometimes we may require to find the extreme values of the function of 3 or more variables. Okay, 3 or more variables. Say for example, f of x comma y comma z, which are not independent, but are connected by some given relation. But they are connected by some relation of phi of x comma y comma z equal to 0. X, y, z are connected by some relation like this. So the extreme values of this function in such a situation are called constrained extreme values. Constrained extreme values. Okay, so we need to find the maxima minima value subject to this condition or subject to this constraint. Okay, so we call these are constrained extreme values. Okay, so in such a situation, we use phi of x comma y comma z equal to 0 to eliminate one of the variables, say z from the given function. Then you should convert the function of two variables. You should write z in terms of x and y and substitute here. You should convert the function of three variables into two variables. Okay, then find the constrained extreme values of the converted problem. So this is constrained maxima minima. Okay, when this procedure is not applicable, okay, suppose this procedure is very difficult, sometimes it is not applicable, we can use Lagrange's method, which is comparatively simpler. But there are some drawbacks for Lagrange's method. So I will discuss with you Lagrange's method the next class. For this class, I am going to discuss only constrained maxima minima. That is, suppose if you have a function of three variables subject to some conditions, I am going to convert into function of two variables. Once we convert it into function of two variables, you know the method. Okay, now the problem is in a triangle ABC. Okay, I think this is a little bit bigger. Okay, I can't finish this problem now. Okay, so that's why I'll choose a simpler problem. Find the minimum value of . minimum value of x square plus y square plus z square when x plus y plus z equal to 3a. So now I am going to convert z is equal to in terms of x and y. So z equal to 3a minus x minus y and substitute here and convert it to function of two variables. And then I am going to solve this problem. Even this problem you can do by Lagrange's method also. Okay. So once I discuss with you Lagrange's method, you can solve the same problem by Lagrange's method. Now, solution. So is from this equation, z equal to 3a minus x minus y. So x square plus y square plus z square. You can write f of x comma y equal to x square plus y square. Instead of z square, I'm going to write 3a minus x minus y. Okay, now this is a function of two variables. This is a function of two variables. So now find fx. Fx is 2x. 2x. Here, if you differentiate this, you get 2 into, here have minus sign, so minus 2 into 3a minus x minus y. Fy equal to 2y. Again, here have minus sign, so minus 2 into 3a minus x minus y. Fxx with 2 and plus 2x. If you differentiate with respect to x, you will get 2. So 2 plus 2 is 4. Fxy. Fxy is this is 0. So 2y. So 2. Fyy. Fyy is 2 plus 2y. So plus 2 will get 4. So now a is constant, b is constant, c is constant. So whatever value, if you get stationary points from fx, fy, your conclusion should be here what? Delta is what? Delta is greater than 0 and a is greater than 0. Whatever the stationary points you will get, that point is what? Is a maximum point or minimum point?
Minimum point.
Minimum point.
Yeah, minimum point. Yes. So now solve fx is equal to 0 and fy equal to 0. Fx is equal to 0 implies 2x minus 2 into, we check it, 2 into 3a minus x minus y equal to 0. Throughout divide by 2. So x is equal to 3a minus x minus y or 2x plus y equal to 3a. This is equation 1. So fy equal to 0 implies 2y minus the same thing. Okay, 2y minus 2 into 3a minus x minus y. So which is equal to 0. Throughout divide by 2. So you get x plus 2y equal to 3. So what is the value of x and y? If you solve equation 1 and 2, what is x, what is y?
A comma
A
A.
comma A.
A comma a. Okay. So x is equal to a, y equal to a. So a comma a is a stationary point. stationary point. So now at a comma a and okay at a, so we know that at a comma a, capital A equal to 4, capital B equal to 2, capital C equal to 4, and the delta equal to 16 minus 4, that is 12, which is greater than 0. So this implies delta greater than 0 and A greater than 0. So this implies the point A comma A is the minimum point. And the minimum value of therefore the minimum value of f of x comma y at 0 comma 0 is f of x comma y equal to a square plus a square plus a square equal to 3a square. Okay, now I'll give some more column for practice. So please write down these 3 columns. First column, x power 4 plus x square y plus y square at the origin. So I am not writing in the whiteboard. So because already I wrote for some other section. So please write down quickly. I think I gave this column. The first column I already gave, so there is no need to write. Second column, show that the function f of x comma y equal to x cube plus y cube minus 63 into x plus y plus 12xy is maximum at minus 7 comma plus 7 is maximum at minus 7 comma plus 7 and the minimum at 3 comma 3. So stationary points for this function is minus 7 comma plus 7, 3 comma 3, and then 5 comma minus 1 and minus 1 comma 5. And third column, find the maximum or minimum of the function f of x comma y equal to 2 into x square minus y square, 2 into x square minus y square minus x power 4 plus y power 4. So this is a function. For this function, totally 9 stationary points: 0, 0, 0, 1, 0, minus 1, 1, 1, 1, minus 1, 1, 0, minus 1, 0, minus 1, comma 1, minus 1, comma 1, minus 1, comma minus 1. So some other points maybe gives minimum value, some other points will give maximum value, some other points are saddle point. Some other points, the case is doubtful, further investigation is needed. So we should discuss these things. So now I'm going to give one more column here. Let us try. Otherwise, we will discuss in the next class. A rectangular box. Okay, so it is better to I will do this column in the next class. So before this, so I want to show you those who submitted second assignment, because some of the students don't know how to submit the assignment properly. Even they sometimes submitted the assignment, but it shows missing. So that's why, for clarification, I am going to show you here, out of 52 students, 35 students submitted the second assignment. So please check your name is here. Okay, Suppose your name is missing, then suppose if you submitted the assignment, please check your GCR. Please check your GCR. So this is the submitted students list. So if anybody wants to show those who are not submitted, then I will show you. Otherwise, I will leave it. Okay, the remaining 17 students are not submitted. Suppose if you submitted, your name is not here, so then you can tell now. Okay, so I think now time is 9:45. Okay, thank you. We will meet again tomorrow.
Thank you, sir.
Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you.
Thank you,
Thank you.
sir.
Thanks.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you so much.